and its angles greater than 360. What does that even mean? Can angles be greater than 360?
Yes.
No.
Numerically, they can't.
Oh, take that.
This is 90,
No.
180, 270,
360.
360. So if you have greater, let's say you have 420 degrees. What does that mean? It means you go around, you reach 360, and then what happens? You keep on going until you reach 420, which would be 60 degrees. So 420 degrees is the same as 60 degrees, but you add an extra spin. Later on, that has its consequences when solving an equation. For now, just understand that if you go around, if you get, let's do another one, I don't know, 510. How much would that be?
150.
360? And then 90 would be 450? And 90 would be
No, 60.
less than, if this is 450
450
plus 60. So this would be, how much here?
30.
Very good. 30 degrees on the second quadrant. That's 510. Does that make sense? When it comes to problems with this, the fact that it's over 360 only tells you which quadrant it falls into. Once you know which quadrant it falls into, you get the sign of the trigonometric function in that quadrant. So, let's do one. Let's say you get cosine of 570 plus sine of minus 765. Don't freak out, it's fine. It's okay. Cosine 570. Let's do that one first. 210. How'd you get to 210? Minus 360. You all did that. You just subtract 360. So 210. 90, 180, 210. It's 30 here. 60 on the other side, but remember that even though you can do it on both sides, it doesn't matter. As a standard, we just do it in terms of the x-axis, okay? So that one's here. What about this one?
That would be 45.
This one's negative, and it goes the other way. How did you know it was 45?
Because if you got 360 times 2 minus...
That's 720.
And 765 minus 720.
You've got 45 left. Okay.
But
So we're
since
going
it's-
this way, right?
Yeah.
So it's 45 here.
Wait, how did you do that?
This is 720. 720 is 360 going around twice, right? So 760 minus 720, you got 45 left. And it's a negative, so we know it's in this direction, right? So we've got the cosine of 30 in the fourth quadrant. So cosine of 30 here. This is a 1.
That's a 1. That's...
This is 2, and this is square root of 3. And cosine is negative. Sorry, cosine is adjacent over hypotenuse. Adjacent square root of 3 over 2. Positive or negative?
Negative.
Negative, because the square root of 3 is negative on the negative side of the x. So negative. Plus, here, sine. This is 45, so this is 1, this is 1, and this is square root of 2.
1 over square root.
1 over square root of 2, but it's sine, so it's a negative. Right? Did you understand why it's a negative?
Yeah, because it's on the middle.
Because it's going down, so it's negative. So it's negative square root of 3 over 2 plus negative minus square root of 2 over 2.
Oh, because that's the same.
Yes, so it's the square root of 3 minus square root of 2 over 2. And that's your answer.
Can you Square root of 2.
You can with decimals. You can't if you leave it like this. If it were the square root of 3 minus the square root of 3, yes, but it's not. No, you can't. This is two different numbers, okay? Questions on that?
Do you
No?
have to graph every time?
Yes, because you need to know where you are. Because the quadrant tells you if it's positive or negative. So if you don't graph, unless you're really good at it, I have to see it. But if you are not a visual person and you have it in your head, you don't have to. But my experience is if you don't graph it, you usually tend to make mistakes with the signs. So it's up to you. Boat in the river problems. May I erase?
Maybe.
Oh, that one.
10 6.
That's the second part of the lesson.
10 7.
Didn't we do the boat in the river already?
Yes, we've done them for the past 3 years.
3 10 7.
But just a quick review.
96.
Oh my god.
Just a quick review with the boat in the river problems. It's boat in the river problems,
Oh,
airplanes
I
in
remember
the
this.
air problems. It's anything that has a current, it could be fluid, water, air, and something that's going against it or with it. Why? Just like when you're walking in the airport and you walk on those strips, if you stand on them, the people that are walking next to you are walking faster because the bands usually tend to be quite slow, but it's easy to be on them because you're not carrying the luggage, right? It's being carried for you. But if you are in a hurry, isn't it really cool when you start walking and you go really fast and then you reach the end, it's like, right?
A break.
Why does that happen?
You're going with the how
Gravity.
fast the
Because
band
the
is
river
going,
is how
plus
fast it currents.
how fast you're walking.
So you go faster because it's the speed of the band plus the belt plus your speed. But if you tried to go against the belt, what would happen? You'd go slower because it's the speed of the belt. It's your speed minus the speed of the belt. That's the same exact principle that happens with boat in the river problems. If you're rowing with the current, are you going faster or slower? Faster, because it's the speed of the current plus your speed of the boat rowing. If you don't row, you're just going to have the speed of the current. And if you go against the current, are you going to go faster or slower? Slower, because it's what you're rowing minus the speed of the current. That's where the formulas come from. So you have, I'm going to call it a vessel, okay? V for vessel. Speed of the vessel. Because it can be a plane also, against the speed of the air current. So the vessel plus the speed of the, you want to call it fluid? Because it can be air or it can be water.
Yeah. Oh,
Fluid is anything that flows, so it can be water, it can be oil, it can be whatever that flows. Ketchup flows slowly, but it flows honey. Speed of times the time.
Equal to this.
This is speed, right? This is a rate, remember? This is a rate. Times the time equals, rate times time equals distance. But if it's plus, are you going with the current
I can.
or against it?
Again.
If it's plus, are you going faster or slower?
Faster.
With. And if it's with, it's downstream, right? So I'm going to call this downstream. So this is downstream. Along that same line, upstream. What would happen upstream?
It will be negative instead of positive.
What would be negative? What would you subtract?
D minus F.
The speed of the fluid is the one you subtract because it's what the vessel is going at minus the speed of the fluid times the time upward, distance upward. And then it's just finding out what they give you and
Put it-
substituting and finding what you don't have, basically. Do you want us to do an example or you're good?
We're good.
You're good? Joanna, you're good?